Hello everybody, this is Mr. Loy, your friendly D&T teacher. This is our third worksheet of the full HBL for Set 3NA Electronics technological area. So remember the last training video, I skipped the bipolar transistor. Today we are going to visit it in detail. So this is the worksheet. Before we start, you've got to have a few things with you as well, okay? Besides your writing materials, this 2-page worksheet itself, your D&T revision guide, right? Specifically page 55, as well as your D&T textbook, all right, on page 285, right? So have them ready before we start. Right, so how are we going to go about tackling this worksheet here? As you can see, the first half of this part of the worksheet, the questions basically tests you, assesses you on with the recall knowledge, the basic functions of transistor, how you actually draw the symbol, and to name the various pin positions, or we call it the legs of the transistor. The lower part of page 1, all right, actually assesses you on the application knowledge, how looking at a incomplete circuit, you need to recall and remember how to complete the circuit with the other components as stated by the questions requirements here. Moving on to the second page, it again assesses you on the understanding of using the 1 kilo ohm resistor in the circuitry where you involve the use of transistors. Then this is the application question again, assesses you on your ability to analyze and understand the various components required to change, all right, in the circuitry in order for you to form a working circuit here. Last but not least, again a recall question on the purpose of a 680 ohm resistor. Why is it necessary to have it before the light emitting diode, which you actually learn in tutorial 1 and unit 14 electronics. And last but not least, down here, again, assesses you the ability to understand how you can actually tweak a part of the component to vary the sensitivity of the circuit. So with this in mind, we're going to proceed on to using your D&T revision guide as well as your textbook and complete this circuit, this worksheet. Okay, right. So this is how I will present the answering of the first part of the worksheet. So as you can see, question 1 asks you to draw the circuit symbol for 2 types of transistors, NPN and PNP transistor, and also to explain the basic operation of a NPN transistor. So first of all, transistors by and large exist in 2 main categories. One is the bipolar junction transistor, BJT in short, which is the one that we are looking at our secondary level. And there's this other field effect transistor, which we are not looking at it. Now also, you need to know that the transistor is a semiconductor device, meaning it has what we call doped semiconductor material such as carbon nanotubes that is actually built between the junctions, for example, the base to the collector and from the base to the emitter. So the details of how this electron flow actually works is not at our level, okay? It's beyond the level. So of course, if you aspire to be an engineer, electrical and electronics engineering, you should consider looking at, perhaps you may want to look at going into polytechnic and things like that. Right, so for us to draw the NPN transistor, NPN here stands for negative, positive, negative, all right? So first of all, you draw the base entry, the pin. This is actually the base here. This is the lead of the transistor. And then you draw outwards this way, and you bring it down from the positive terminal down to the negative terminal. Now, the arrow that you place determines whether it's a NPN or a PNP. So for a negative, positive, negative transistor, your arrow is actually here. Now, you may also see that in some textbooks and whatever, revision guide and so on and so forth, you will see this circle encompassing the circuit symbol. This is also acceptable, all right? And in your work solution, which will be shared soon, you'll find the arrow is actually drawn slightly before the turning point. So they are all acceptable, okay? So obviously, previously I mentioned in the previous video, go for the simpler drawing, but you must at least know the other symbols as well. So before we move on to drawing the circuit symbol for PNP transistor, it is important that you label the leg positions. For example, B for base of the transistor, this is your emitter, and this is your collector leg or pin of the transistor. So let's move on to PNP. The circuit symbol, you can expect that it doesn't actually change much, except, like I said before, the direction of the arrow actually will decide whether it's NPN or PNP. So in this case, the arrow points towards the base. Similarly, this is base, this is still emitter, and this is collector. Right? If you want to include the circle, you just draw the circle, covering the 3 pin positions. So why the direction change of the arrows? It has got largely to do with how electron actually flows through both the junctions. All right. For example, the negative to the positive junction between the collector and the base, and from the base to the emitter, the flow of the electron itself. So at this level, you do not need to know the electron flow. As of the basic operation, you need to explain the basic operation of the NPN transistor. So down here, all right, what we know is that this transistor is actually an automatic switch. So what it means is that instead of reaching a physical switch in your classroom, for example, to turn on your ceiling fan or your lights, there's no physical switch to actually turn on a circuit. This transistor acts as your automatic switch. It turns on electronically, either it's on or off. And so I'll just write the first sentence describing the transistor in general. It is a semiconductor device acting as a automatic switch. Now, semiconductor, in your previous tutorial, Unit 14 Electronics, you have actually learned that this material actually allows current to flow through, but not as freely. To allow current to flow through easily, those materials are considered as electrical conductors, all right, such as gold, steel, copper, and so on and so forth. So this is some form of a carbon material, so it doesn't really allow current to flow through easily. Now, this is generally describing what it actually looks like, but you have not actually talked about how it actually works. So the next portion for basic operation will be to describe in detail a little bit more how this transistor is turned on. So let's start, okay? When a little current, all right, passing through the base, okay, which we use a voltage difference, this part here, this is the voltage across the base and the emitter junction, greater than 0.7 volts, the transistor is now turned on. Then what would happen actually? So what happens is that it allows a larger current to actually pass through the collector, through the base, and up through the emitter. So turning on any output devices there. Okay, so you can actually complete the sentence, which I'll pause for here. So as you can see, it allows a larger current to flow through from the collector, through the base, up to the emitter, back to the power supply, thus switching on an output device such as a LED. All right, usually the output device is connected between the power supply as well as the collector. Now from here, of course, it leads us to answering the middle part of this worksheet here. It says the base, which is the lead or terminal or pin responsible for activating, alright, or turning on the transistor. And of course the collector, which is up here, which is the positive lead, and the emitter will be your negative lead. Now the video may actually stretch a few minutes more, so I have decided to make it into bite size. And of course you can always pause the video at any point in time. You can rewind it and replay it. Okay, so see you later.